Shenyang, how would you prove that the Earth is round?
A photo of Earth taken from space is the most convincing proof.
This is the most widely circulated photo of Earth. Taken in 1972 by astronauts on Apollo 17, Earth looked like a blue marble to them, hence the name.
Seeing it from space is pretty straightforward, but for ancient people, understanding Earth was a big challenge. In ancient times, limited to their surroundings, people thought the world was flat based on what they saw. So, different civilizations created their own ideas about the world based on their experiences and imaginations. For example, ancient Chinese believed the sky was round like a dome and the earth was square, with humans in the center. Ancient Russians thought the earth was a flat disk carried on the backs of 3 giant whales, floating in a vast ocean. The ancient Indians had a more imaginative idea, believing Earth was carried on the back of a giant elephant, and earthquakes were caused when the elephant moved. However, the ancient Greeks, with their advanced sea trade, noticed something strange. They noticed that when ships sailed over the horizon, the hull disappeared before the sails, suggesting a curved surface.
This is an offshore wind farm in Belgium. The left image shows the whole windmill, and the right shows it from a distance. You can see the bottom part disappearing below the horizon, showing Earth's curved surface.
As far as I know, Aristotle was the first to use physical phenomena to prove Earth is a sphere. Besides ships at sea, he cited other examples. For example, during a lunar eclipse, the Earth's shadow on the moon is curved. Or, if you travel north or south, the stars near the horizon change.
Compared to that, Pythagoras' reason for thinking Earth was a sphere seems a bit simplistic. It was just because he thought a sphere was the perfect shape.
That's not very convincing, but he was still impressive for being the first to suggest it. But I think Eratosthenes was the most impressive. He calculated the circumference of the Earth using just astronomical observations and simple geometry.
Eratosthenes was born in Cyrene, a Greek colony in North Africa, modern-day Libya. He was well educated in Cyrene and Athens, becoming a learned philosopher, poet, astronomer, and geographer.
He calculated Earth's circumference to be about 40,000 kilometers. Compared to today's measurement of 40,075 kilometers, it was very accurate. Over 1,700 years later, Magellan's circumnavigation proved Earth was round. With advances in technology, we have more models and images of Earth, giving us a clear understanding of it.
It's a privilege to build on the work of these pioneers and continue exploring the unknown.
Maybe one day, our understanding of the universe will be as clear and intuitive as our understanding of Earth is now.
It definitely will. Xiaomi, how did Eratosthenes measure the Earth's circumference?
This story begins with his role as the chief librarian of the Library of Alexandria.
The Library of Alexandria was one of the largest and most important libraries in the ancient world. It was filled with books acquired through purchases and copies made by scribes. The library was located in the Temple of the Muses and offered generous salaries, free board, and lodging to international scholars, poets, and philosophers, allowing them to focus on their research.
Eratosthenes wanted to create a world map based on the library's resources. Before he started, he wanted to know the size of the Earth.
Eratosthenes heard about a well in Syene, modern-day Aswan, where the sun shone directly into the well at noon on the summer solstice, casting no shadow.
Modern science can easily explain this. Syene, which is today's Aswan in Egypt, lies directly on the Tropic of Cancer. So, he designed an experiment based on this phenomenon.
First, Eratosthenes assumed that the sun was so far away that its rays could be considered parallel when they reached Earth. Next, he measured the shadow cast by a tall obelisk in Alexandria at high noon on the summer solstice. Through his calculations, he determined that the angle between the obelisk and the sun's rays was 1/50th of a circle.
Then, he applied a mathematical theorem. When two parallel lines are intersected by a transversal, the alternate interior angles are equal.
For example, angles A and B in the diagram are alternate interior angles. If the two lines are parallel, then angles A and B are equal. Based on this principle, the angle formed by the obelisk, the well, and the center of the Earth was also 1/50th of a circle. Eratosthenes then hired surveyors to measure the distance between the two cities, which was about 5,000 stadia or 800 kilometers.
Based on the information, please write a formula to calculate the Earth's circumference. This is a reproduction of Eratosthenes' map, and you can see it's very close to reality.
Eratosthenes divided the map into sections using parallel lines to accurately describe different regions. This was the early form of our modern latitude and longitude system. For this, Eratosthenes is called the father of geography.
He was so skilled in both mathematics and geography that people called him both a mathematician among geographers and a geographer among mathematicians.
Which word is associated with Eratosthenes? On which date did Eratosthenes conduct his experiment? It took humans a long time to figure out what the Earth is like. Modern science shows that it's almost a perfect sphere. Eratosthenes was the first person to measure the Earth's circumference. When two lines are parallel, the corresponding angles on opposite sides of a transversal are equal.
Now, let's do some Python exercises for this story. For any explanation on the terms or the words in this article, we can do it with the AI assistant. So just highlight these words or term like Tropic of Cancer and click on the explain words. AI will do it for us. Great job. And if we want to know the date for the summer solstice, we can do the same. Okay. So according to Eratosthenes, here in this diagram, the arc length corresponding to 1/5 of the Earth's central angle of the distance from the Sinai to Alexandria between these 2 points is equivalent to 1/5 of the Earth's circumference. Okay? Since they are similar triangles. So Eratosthenes learned from the local merchants that the distance between the two cities are 5,000 stadia, the unit of measure in the ancient Greece. Okay. So there's a formula calculated by Eratosthenes that we can get for Earth's circumference. It's 5,000 multiplied by 0.16 multiplied by 50. Okay, now we need to use Python to calculate the Earth's circumference in kilometers. We just write down the formula according to a description above. (5,000) multiplied by 0.16 multiplied by 50. Okay. So it's 40,000 kilometers for Earth's circumference. Now we can do a painting work that draw the Earth based on the calculated circumference. So this is the code of the Python to do the engine work. We need to firstly run it. Okay. If you got any question regarding the code, and if you want to know more about the code, you can click on the cell and click on the explain button on the right corner, right above corner, and you can have the explanation line by line. Okay. Great. Thanks, AI. And now we can replace this question mark with the Earth's circumference that we calculated above, which is 40,000. 1, 2, 3, 4. Okay. Now we can see this is a blue circle represents the Earth, and there's a gray circle represents the moon. Congratulations, you have successfully completed this drawing.